Okay, looks like most of our folks have got audio going. Good afternoon, everyone, and welcome to another Lunch and Learn with KukerRanken. We're really excited to be here with you today. And today we're going to be going a little bit deeper into our ANYmal application and mobile scanning. So with that and no further comment, I'm going to turn it right over to Brady Reisch of EDC here at KukerRanken. So Brady, the floor is yours.
Perfect. Thank you so much, Douglas. And thank you everybody for coming and spending about 30 minutes with us here today. So let's go ahead and just start diving right on in, because what are we here to do? We want to look at some new information. So who am I and why am I presenting this information? My name is Brady Reisch. I am, as Douglas mentioned, the virtual design and construction reality capture specialist at Kuker-Ranken. Probably the longest title anyone has ever heard of, but that's okay. It's quite a mouthful. I'm a CFR 14107 certified pilot. I used to have a lot of enterprise tech support in my background. I'm an instructor and really I guess co-in charge of our robotics division here at Kuker-Ranken, which includes anything from aerial and terrestrial robotic systems. So today specifically, we want to talk about the ANYmal itself. So the ANYmal is a quadrupedal robot. The runtime, some of the generic questions or most common questions are, how long does it run? Well, it's about an hour and a half. It takes about the same time to charge. This is an industrial robot, so it is IP67 rated, which means that we can actually walk this underwater, fully submerged, for about 90 minutes down to about 3 meters or so. And this is for the ANYmal itself. This does not include the ARC scanner that we have included on the ANYmal right now. We'll talk about that rating here in just a moment. But really, the ANYmal is just a means of getting a specific sensor to a specific place. So in this case, what we're trying to do is make sure we can put a high-resolution SLAM LiDAR system, the ARC, onto the ANYmal and put it into some of these areas. Well, there might be some different things we need to crawl over or around or upstairs, for example. So the ANYmal is an excellent tool in order to get a sensor to a specific location. So the ANYmal is also outfitted with omnidirectional optical avoidance using depth sensors on all sides of the ANYmal itself. So it just looks and sees if it's something that it's able to crawl up and over. It doesn't understand objects. It just understands that there's a surface and I can try to manipulate and move around. And then finally, again, touching base on, it is an industrial design to withstand hazardous environments. So whether this is going to be culverts, inspections, if this is going to go into a environmental catastrophe for some reason, rubble, rocks, debris, anything that's about 13 inches or less, the ANYmal is able to crawl up and over or navigate around in certain modes. So the ANYmal is just a great way in order to get, like I said, our sensor to a specific place without sending in a person. I'll show you a couple examples here where I certainly don't want to go. Then we also have the BLKARC system from Leica. This has a 270-degree horizontal and 360-degree vertical field of view. So vertical, it's looking up and down at the same time. Horizontal, we have about 270 degrees, so it doesn't scan the back because we don't want to scan our payload on the ANYmal itself. Our effective range is anywhere from about 0.5 meter to 25 meters. I'll show you an example of something that is beyond that 25-meter range and something that's very, very close. You'll also notice on the picture with the ARC, these two little horns sticking out on the side. This is within that 0.5 meter range. So this is not scanning, it's actually scanning around it. So it gets rid of those horns so it's not stuck in your data. So the BLKARC system is able to scan 420,000 points per second. That's a lot of data. It has 12 megapixels combined with all the cameras. It is IP54 rated, which just means that it is water resistant, but not waterproof. So not fully submergible, but if you get caught in the rain, it's okay. And it should survive as long as it's not a torrential downpour. We have a very high degree temperature, so 0 to 35 Celsius operating temperatures. And we can store up to 24 hours of continuous scanning in compressed data formats, or we can basically scan up to 6 hours with uncompressed data. And our noise range is somewhere between plus or minus 3 millimeters. with this data. So it's a very effective unit, and we'll talk a little bit about why we would want to use a SLAM LiDAR versus a terrestrial or a traditional terrestrial scanner system. So there are many different options that we can utilize. However, the ARC itself is best suited for the animal because it's scanning as we are moving. We don't have to stop and scan in every location. So I'm going to play a little video clip while we're just talking here in the background. So this system was captured with an ARC on a quadrupedal robot walking through this facility. So this is cut through solid rock, and then there's going to be an industrial facility behind this as this goes along. This is about a 2-minute video while we're talking. So you can see the point density that we have. It's not as dense as, say, we would get with an RTC 360, which is a traditional scanning system we would use for high resolution scanning, because the RTC would stop and scan for anywhere from about 1 minute to about 3 minutes per scan. Then we'd have to move it down the way X distance, depending on how much we're scanning and what the distance of the scan would be. Stop, scan again. So now we have 2 registration points, and then we have to basically tie those together. The RTC has viz technology to help us with that, to then kind of pre-align those scans together. And then we would go through register 360 and actually tie that and say, yes, this is correct, or no, we need to make some adjustments and tweak the model so it fits correctly, and then finish that registration process. With a SLAM LiDAR unit, like on the ANYmal with the BLKARC system, we are able to walk and scan at the same time, which means we are drastically increasing our efficiency as long as we can get away with slightly less accuracy than we would get with a traditional terrestrial LiDAR system. So we kind of have to sacrifice either the efficiency of running the system or the quality of the data. And this is enough for most people in order to utilize the ARC system on a quadrupedal robot, or even using a BLK2Go, which is the same sensor, just handheld versus being put onto a robot of some kind. So you can see from this video, we get great data out of the ARC itself. And this is plenty enough for this client who was basically trying to figure out what their retrofit with some of their new equipment would be. So they needed current as-built conditions so that they can determine how we're going to manipulate that, move it, and then put in the new equipment. So this is just a way to make sure you're getting what we would refer to as a digital twin. And you hear that term a lot here nowadays. So the other thing that I really wanted to talk about is in hazardous environments where we don't want to send people, such as down into a culvert. We don't know what is in that water. We don't know if that water is toxic. We don't know if there's glass shards or needles or rebar sticking down there, and maybe you're walking around with waterproof boots, and all of a sudden you puncture the boot and it goes through your foot. It's a very bad situation, and it's very hazardous to put a person into these environments. So what we've done is take the ANYmal and actually put it into the culverts and scanned this data, and I'll show you the data set from this specific scan in just a moment as well. And the ANYmal itself is able to walk through and manipulate anything, or maneuver around or above anything that is 13 inches or less. So you'll see him kind of picking his feet up, kind of making a little bit of a splash, just going into this muddy, murky water where we don't want to go down there as a person because of safety concerns. And so all we did on this, you'll see that we have a tether on him. This just means that if something was to happen, we can just pull him right back out without having to go in and retrieve the animal itself. But you can see on our ANYmal, we do have the front inspection payload, which is kind of this grayish, silverish payload on the very front, which has thermal, RGB, sound sensing, and it's got a spotlight. Then behind that, kind of right in the middle, we do have our black BLKARC system that is continually scanning. So as we are walking, we are scanning the entire thing just as is. It makes it so wonderful. So I'm going to go ahead and change my window here for just a moment. So we'll stop our share and bring it right back up for you. So you can see what this data really looks like, right? Instead of just showing you what is the marketing data, what does it really look like in the real world? Well, that's the beauty of this. We're able to show all this information for you. So here we're looking at Cyclone Register 360. This is where we take all the raw data from the sensor and then process it into something that we can see and do measurements on. So as we're moving around here, I find it's a little easier to look at this in a grayscale. I'll go ahead and turn on our color value so you can see we capture color information from the sensor. So we've got our brown dirt, we've got our trees, some are green, and you see a lot of the white because it was capturing images from the sky. So it just kind of makes it a little whitish on all of the branches and leaves that are coming down. So I find it's a little distracting to look at it in this mode, which is why we're going back to the grayscale. I think it's much easier to see this data here. And I apologize, let me change my gradient here on the background. Now we have our data. So I'm going to zoom out and show you what we did with the ANYmal is we had taken the ANYmal from one side of this culvert underneath and scanned all the way to the other side. So we can walk through this and see exactly what's going on. This was not scanned on top. This is all internal data. On top, there's a road here, which we can always augment or add in later on. So we'll come down. This is pretty steep to get down into this little small little creek here to get into the culvert where all the water is going. So we were able to put the ANYmal down, stand him up down the bottom, and start walking him through this area. So as we come in, as we're zooming in a little bit, we see there are things sticking up above the water. The LiDAR scan, of course, does not scan anything below the water. Nothing would be measurable, even if we would see something through the something that's very, very shallow. So that's why we kind of have this flat bottom, and that's the water that we're looking at. As we move in, I want to direct our attention to this upper left corner of the culvert. What we can see is there's a lot of color change right here. This is indicating that there is actually water penetration or something seeping through the concrete itself in this culvert, which means it's not retaining the water the way that it should be or keeping other water out of this potentially toxic water source. So if we change back to our color for just a moment, oh, excuse me, wrong color here. We can see there is the color change. So it's just saying that this is moisture of some kind. So this would be an inspection point that we can come back to, take images of, and do an analysis on and figure out what is happening in that area. So if we move through our tunnel here, you'll also see on the right-hand side, we've got a lot of the dirt, mud, and muck and junk that has just really built up over the years. So we want to make sure we're staying out of this as a human for safety purposes. We don't want to be trudging through the water, which is why we put the ANYmal through. But you can see, we see all the break lines in the concrete. We can see stress fractures. We can gather in a multitude of different types of sensor payloads in order to run analysis on this data. As we go to this other side here, I also want to point out we also have another pipe that is running perpendicular through this culvert itself. I don't know if this is freshwater. I am not sure, but we've gathered information to verify that this pipe itself is not deformed. It's not going at a weird angle. It is exactly where it needs to be. We don't see any stress line fractures or hairline cracks, which means that we don't have any contamination between these two sources of likely of water that's going through this pipe as well. And as we come out the other side, we basically walked out and walked back through it. So we captured some of the side retaining wall data where the road basically passes right over the top of this, so a very small little bridge. So amazing data that comes out of something that we ran, and we were able to basically walk within about 5 minutes. So let's get it up, start scan, walk it down, walk it back, and then we go back to the office and process this data within something like Register 360, and then we can do different analysis through different types of programs, such as like a 3DR. So speaking of 3DR, I have another data set that I'd like to show you really quickly. So if you're with me for just a moment to get that started. So this one, again, is another bridge, but a little bit bigger. This one we had captured just to walk down and back. This is a great example to show what the deviation would be when you start getting beyond your 25-meter range for the ARC system. So to give you a little background, let me back this up here a little bit. I'm going to change my view so you can see this. So this is a large culvert. This is storm drainage. We have a very steep angle right here where it looks like it's missing a lot of data because we did not walk on the very bottom. So this angle is about 45 to 50 degrees, which means it would be a little treacherous for the animal to get down without a tether. And we just didn't have a tether at the time. So we just walked along this ridge down on top. And we can see we already captured some information down below. We captured where we were walking. We captured this wall for the retainer and where the bridge is going to go over the drainage here, or the storm drain, excuse me. Now, if we rotate around a little bit, you'll see we have all the girders, we have struts. So we can see all of this information. We can then put this into a BIM environment to build out the surfaces and then compare it against the existing built or the as-built conditions. So we can verify, again, if there's deformation, deviations, any problems with the data that, or any problems with the existing bridge to see if that was something that needed to be rectified or resolved without having to send people into these environments. So we get this information, and we can always come back to this information. This is going to be geotagged and timestamped. So we can always go back and say, hey, on this date, at this time, when Brady walked the animal through this area, this was the current conditions. So there wasn't any problems, but maybe there was a rainstorm that caused some additional damage that happened 2 weeks down the road. We go walk it again, and we can compare the two data sets together. So you can see just walking the animal straight down and straight back, we've got great data coming out. Now, as I mentioned, the 25-meter range, we can see we started to capture towards the other side, but we didn't capture all of the other side. So ideally, if this was going to be walked for permanent record, we would take the animal down to the bottom and we'd do several scans up and down and scan more of this information to then complete this bridge and this storm drainage canal, if that makes any sense. So with that, we get amazing data with the ANYmal system, which is just a means of getting a sensor to a location and using the BLKARC system. There are some new updates that we're really excited to talk about. Just can't talk about it just yet. Give us a little while. But as soon as you see that there's going to be an update here coming for the BLKARC, we'll be able to show you some even more incredible data coming out of this amazing sensor that's just very, very tiny. So with that, what I'll go ahead and do is throw up my contact information. If we've got any questions, I'd like to go ahead and pose that to the audience. If you'd like to speak up, then we'll be able to get anything answered for you. I'm just checking in through chat. And it looks like our administrator's already gone through to put a link to the animal to our website. So go ahead and check that out, look at some information. If you want additional information, data sets, or use cases, make sure to reach out to your KR representative, and we'll make sure we get you everything that we can on this amazing combination.
So no questions have come through on the chat just yet, Brady. Oh, here we just had one that's come in to us. What's the noise of the wall in this type of sensor after merging point clouds and movement of the robot itself?
So it's really going to depend on how close you get to your subject, right? You may have more error in that. In this specific cloud, we're looking at about 2 millimeters, maybe 3 millimeters at the most for our deformation or our error within the wall itself. As we get spread out towards the other side where we did not scan, the error could go up because we didn't do more passes down below. So there's, as long as you strategically get all the information you need to, you can keep that error very, very low within a couple millimeters.
Outstanding. Well, no further questions are coming through from the Facebook side. Anybody who's attending the local or Facebook, this is your opportunity to ask any questions you may have before we round out for this week.
And as we're waiting just a few moments for any additional questions to come in, if you are interested in seeing the ANYmal run, make sure to reach out and let us know. We are doing a lot of travel currently, and we are traveling mostly on the West Coast as it stands. But we do want to make sure that we can get a visit in so you can see the system in action, from the actual scanning to the processing of this data as well.
It's giving folks a second more here to ask any questions before we run out for the day. So folks, while we're waiting for any last questions to come through, if there are any, I want to make you aware that we have the next week coming up on April 19th, we'll be with Jeremy Kippen and more about the Leica GS18 with various models that are available from Leica. So we're very excited to be able to present that to you. Then the following week on April 26th, we will be meeting the team that created Inspired Flight. Inspired Flight is a U.S. manufactured drone or UAS system. This allows us to be NDAA compliant and even Blue List compliant if you have any need for DoD or similar types of work scenarios. So we'll meet the folks from the Inspired Flight team and get a close-up and deep view of their IF-1200A and their IF-750B platforms, which are made for people that need NDAA compliance or Blue List compliance moving forward. Then following that, on May 3rd, we've got Ben Goddard out of our Salt Lake City store, and he's going to be doing a presentation on battery maintenance, whether it's batteries for your RTC 360 or different types of mobile scanning products, or batteries for your uncrewed aircraft systems. Ben is going to be taking us through how to manage those LiPo and LiHo types of batteries. So we'll look forward to seeing you there on May 3rd. Again, you can always get into our Lunch and Learn series, and we've got a link coming through to you here on the Zoom chat. So we'll look forward to seeing some of you at these next pieces come up. And Jennifer, does that get us through? I think that gets us through all of our chat there.
It does, yeah. It looks like you've got a couple of other questions there.
A few last questions that we can cover real quick.
Oh, I'm not seeing those. Thank you.
So the question is, are there any other sensors available for the ANYmal? And yes, there absolutely are. The ANYmal, I think, is really the Lego of the quadrupedal robot system, where you can put anything you want, anything to your imagination, anything that's going to be under your approximately 30 to 33 pounds. So if you have other gas detection sensors, if you like to have different high resolution payload systems, if you want to put an RTC 360 and stop and do your scans, you can absolutely do that. The integration is all available. There's open SDK. So really the only limitation is your imagination and the weight limit. And then there's another question as well. Does the ANYmal have any power tether that can increase the mission duration? At this time, there is not. However, again, the imagination is your limitation. So there certainly could be a way to do that. You just want to make sure that it is a very powerful cable so that if something was to happen, you're not yanking the cable out of the ANYmal. So that there are some limitations and things we need to think about logistically, but that is absolutely something that could be set up down the road for sure. And it looks like that is rounds out the rest of the chat that we have through our meeting, unless there's anything else through Facebook.
You can kill your screen share there, Brady. That would be great. We can wish everyone well. Outstanding. All right, well, folks, that brings us to the end of another Lunch and Learn for the week. We're glad to have you here with us, and we appreciate your time. We know it's valuable. Please take a look at the Lunch and Learn link that we put in the chat box there so that you can see the upcoming Lunch and Learns and get registered for them. We do have limited space at the Lunch and Learns. There's only room for 50 seats, so you do want to get your registrations in there early if that's something that you're looking to attend. So until next week, thank you for tuning in with us, and we'll see you all again next Wednesday at noon with another KukerRanken Lunch and Learn. Have a great week, everyone.